is polygon angle sum theorem. Polygon angle sum theorem. So we're going to talk, first of all, do you know what a polygon is? Some kind of shape, okay? It's a closed figure, so there's no like openings anywhere in it. It could be like a triangle. What? And no cross lines, right? A triangle, a rectangle, a quadrilateral, a pentagon, a hexagon, those are all polygons, okay? So we're going to be talking about a lot of different sided figures, different shapes. But what the polygon angle sum theorem talks about is in those shapes, what do all the angles add up to? So like we know a triangle, right? Triangle adds up to 180 degrees if you added up all those angles. Anyone know a quadrilateral? 360 for a quadrilateral. If you add up all of its angles, 4 angles added together, it's got to add up to 360. Today, I'm going to teach you a theorem that shows you that you can do that with any number of sides. So I could take 100gon, which is a figure with 100 sides, and I could figure out what the sum of all of its angles would be. Okay, and let me show you why. This is why I love this one, because it's a really cool little, it's not a trick, but cool little thing you can do to figure it out. So everyone knows that a triangle adds up to 180, right? But then we look at this figure and we go, that has 5 sides. I don't know what a 5-sided figure adds up to if we were to add up all the angles. But I can change this into some number of triangles. So if I were to go like this and like that, how many triangles do you see? 3, okay? If there are 3 triangles and each triangle is 180 degrees, we should be able to say 3 times 180 and get the sum of that pentagon's interior angles, right? If I were to take a hexagon and do the same thing, so a triangle here, a triangle here, a triangle here. Now, how many triangles do you see? 4, okay? So this one had, for the number of sides, it had 5. The number of triangles was 3. This one, the number of sides was 6, and the number of triangles was 4. Do you see a pattern happening between the number of sides and the number of triangles? It's 2 less, okay? So here's the trick. The polygon angle sum theorem says the sum of the interior angles of an n-gon, okay, so say we don't know how many sides it has. As long as we can plug it into the formula, n minus 2 times 180, right? Take away 2 and then multiply by 180, we will get the sum of the interior angles. So polygon angle sum theorem says n minus 2 times 180 will equal the sum of the interior angles of a polygon. Okay, if we want to be more specific, it would be of an n-gon, because it's got to be n number of sides, right? So if I plugged that in, straight lines and notability.
I do not know this.
Yeah, it's beautiful. So if you plug in a 7, right, a septagon, or a heptagon, depending on how you prefer to name it, would be 7 minus 2 times 180. A hexagon would be 6 minus 2 times 180. What would a decagon be? 10 minus 2 times 180, right? So you're plugging it in. So the first thing you're going to have to do with this is they'll say find the sum of the interior angles of a, and you pick a number. So we'll say of a 15-gon. Okay. Oh, and I don't have any of my calculator. Plugging in for a 15-gon, 15 minus 2 times 180. So really it's going to be 13 times 180. And when you plug that in, you get 2,340, bless you, degrees. So a 15-sided figure, if you added up all of its angle measures, would add up to 2,340 degrees. Does that make sense? That would be for 4 sides, right? A quadrilateral would be 4 minus 2 times 180. So 2 times 180, which is 360. So it just depends. The number of sides is always what goes in that little box there. However many sides you have, you plug that in, you get the sum. Okay? Questions on that? Okay. With that, they're at times going to talk about what's called a regular polygon. And a regular polygon is just the combination of an equilateral and an equiangular. Now with triangles, they had to coincide, right? If one was equilateral, it was also equiangular. With polygons, it doesn't work that way. So I could have an equilateral polygon. Bear with me, this is not going to look very equilateral. We're going to rewind a little here. Okay, so let's say all of these are the same length, right? Are all those angles the same measure? No, it looks like these two are probably the same, and then all of these are probably the same, but not all of them are the same. So we would call this equilateral. Okay, oh my goodness, sorry. Because all of your sides are the same, but not necessarily all your angles, okay? Or you could also do equiangular, where all your angles are the same, but all your sides are not. So maybe it looks something like, again, bear with me. Let's say all of those are the same measure, okay? But this side has a length of 5, and this side has a length of 2, okay? That is equiangular, because all the angles are the same, but not all the sides are the same. Well, what happens is if you put the two together, so you have equilateral and equiangular, we call that regular. So when they talk about a regular polygon, they are talking about a polygon that has all equal sides and all equal angles. So something like this maybe, where these are all the same and, oops, missed one. These are all the same. Okay, so that would be a regular polygon. Questions on that? Okay, you're going to hear a lot about those in this chapter, so get used to that. Here's the first place you're going to hear about it. This is just a little add-on to the polygon angle sum theorem. What it says is the measure of each interior angle of a regular polygon. Okay, so you can find the sum of the interior angles. What if we want to just find one? Well, if it's a regular, that one is going to be the same as all the others, right? So the way we do that is by taking the n minus 2 times 180. Anyone know what we would do with it then? Divide by what? How many sides? Divide by n, right? So whatever number you plugged in for the number of sides, you're going to divide by that number, and that would give you 1 because they all have to be the same, okay? So it says, we'll just write this out so you have the wording. The measure of each interior angle of a regular polygon is n minus 2 times 180 divided by n. Okay, so this is only if it's regular and you're looking for one angle, right? The earlier one, n minus 2 times 180, we were looking for the sum. We were trying to add them all together. So if it's sum, don't divide. If it's 1 and it's a regular polygon, you'll divide. Okay? Yes, ma'am?
You said that the one you just wrote was regular, looking for one angle?
You're just looking for one angle.
Okay.
Yeah. if you did the division. Okay, so let's say the question is this. What is the measure of one interior? Okay, and those are the key terms here that you need to look for. We're looking for one angle. We're looking for interior. The next thing I'm going to teach you about is the exterior angles. So you're looking for one interior angle of a regular, another key word, octagon. Okay, so regular meaning all the angles are going to be the same and all the sides are going to be the same. And it's an octagon. How many sides in an octagon? 8. Okay, so if I'm looking for one, what am I plugging in here? Oh my goodness. 8 minus 2 times 180. And then what do you got to do? Divide by that number of sides. So whatever was here is going to go here. Okay. So just be careful when you plug this in. You're plugging in 6 times 180 and then dividing by 8. Okay. So 6 times 180, you get 1080 divided by 8. If you simplify that, you get 135 degrees. Okay, questions on that? All right, so what do you think you do if it's not a regular polygon? Okay, let's say for this one, you have this picture. And there's one in your homework that looks an awful lot like this. I did not draw that to scale, sorry. Okay, so let's say you have this picture, and they say, find the measure of angle Y. First of all, is that a regular polygon?
No.
Why not?
Because they don't all equal.
Because your angles are different, right? You have some that are the same, but you definitely have one that's different, at least, right? So it's not regular. So we can't just plug it into n minus 2 times 180 divided by n. But can you tell me the sum of the interior angles of this one? How would you do that? Okay, but before we even touch the 90s, it's what? The sides minus 2 times 180, right? How many sides? 5. Okay, so the first thing we're going to do is we're going to find the sum. 5 minus 2 times 180 is 3 times 180, which is 540. So a pentagon adds up to 540 degrees every time. Okay? How many missing angles do we have? Only one, right? So what you're going to do is just set up an equation where we go 90 plus 138 plus 90. Oh, so messy today. Plus 90 plus y. Okay, so the 5 angles added together should equal 540, and then you're just going to take all of those away. So take this whole batch away from the 540. What does that come out to? 408? So 408 plus the missing angle should equal 540. So you're going to take away the 408, and you get 132 for that missing angle. So it's kind of a two-stepper. You need to find the sum of them. Then you can do the subtraction to take away all the angles we know, and then you'll see what you're left with. Does that make sense? Questions? Okay, so that's the interior stuff. Then there's the exterior stuff. And when we're looking at exterior angles, it's a little bit different. With interior angles in a polygon, we had to do the n minus 2 times 180, and we would get our sum, okay? with the exterior angles, the sum is always the same. It doesn't matter how many sides the figure has, the sum of the exteriors will always work out the same. And let me show you how this works. Okay, let's say we have this triangle. If I put one exterior angle at each angle, and I say this is 100 degrees, this is 30 degrees, and this is 50 degrees, okay? What would this exterior angle equal? If the one next to it's 100, and it's forming a straight line, it would be 80, right? So this is 80 degrees. What would this guy here equal? 130 to add up to 180 with the 50, so this is 130. And then this one would be 150 to add up to 180 there. Well, if you take those three exteriors, so just one exterior angle at each vertex, and you add them together, 150 plus 130 plus 80 comes out to 360 degrees, okay? That will happen every single time. It will always be a sum of 360, okay? So with exteriors, always 360. With interiors, n minus 2 times 180, okay? So that's what the polygon exterior angle sum theorem says, is that if you have one exterior angle on each vertex, the sum will always be 360. So what if I gave you this problem? I'm going to draw you an octagon real quick. And we're going to pretend it's a regular octagon, even though it doesn't look like it. Okay, so let's say this is a regular octagon. What do you know about a regular octagon? 8 sides. What does the regular mean? All the angles are equal, all the sides are equal, right? So that means every one of these interior angles is the same. Okay, my question is, what would the measure of angle 1 be? Now there's 2 ways you can go about this, right? You can find the interior angles and then subtract from 180 and find your exterior. Or we know all the exterior angles have to add up to what?
180.
Not 180. 360, right? So if the exteriors have to add up to 360, and there are 1, 2, 3, 4, 5, 6, 7, 8, right? Because we just do one exterior from each vertex. Then we should just be able to say 360 divided by 8 will give us what angle 1 works out to, right? 360 divided by the number of angles. So that comes out to 45 degrees, okay? Now, if you forget that, that's okay, because you know another way to get there. You could do, so this is round 2 here. You don't need to do this. This is if you don't remember to do this, okay? You could do 8 minus 2 times 180 divided by 8 will give you one interior angle. Okay, so if you do that, 6 times 180 divided by 8, you get 135. How does that 135, so that would be like this angle here, right, is 135. How does that help us get the exterior? Right, subtract 180 minus 135 because this makes a straight line. 180 minus 135 is, what do you know, 45 degrees. Okay, so there are 2 ways to get there. This one is quicker because you're just doing 360 divided by the number of exterior angles that you have. But if you forget it, 135 from 180 will give you that 45 degrees as well. Yeah, Cal.
So with the top one, it's automatically 360 and we have 8 sides, so you just divide it.
So 360 divided by 8. So if I said, what's the measure of one exterior angle in a regular decagon, right? You would do 360 divided by 10, and that would be 36. Okay, if I said, what's the measure of one exterior angle in a regular 15-gon, you'd go 360 divided by 15. So pay really close attention to if I ask you for exterior versus interior. Pay really close attention to, does it say it's a regular polygon? Because if it's regular, they're all the same. If it doesn't say regular, they don't all have to be the same. Okay? But yeah, there's a lot of little keywords that help you out with this stuff. Any other questions on that?